Welcome to Ask Caleffi, the podcast that dives into real-life problems that plumbing and HVAC technicians face in the field. We're your hosts from the Caleffi Tech Support Team. I'm Greg Tubbs.
And I'm Dan Furcus. Welcome. We look forward to sharing some stories from our tech calls and using our background and expertise to make your days a little easier.
Hey there, welcome back to another episode of the Ask Caleffi podcast. I got Dan in the studio with me, and what are we doing today?
Oh, we're going to talk to Cody Mack again about his 5 Things You Need to Know series.
Oh, he's a return victim.
Yeah.
I know.
Yeah, welcome back.
I'm glutton for punishment, gentlemen. What can I say?
Yeah, you are. Well, it doesn't help that you basically reside right across the cubicles from us, so
Yeah.
we can throw paper airplanes at you whenever we want.
We can talk all about the downsides of working at Caleffi, but let's move on.
Okay.
No, you guys are a pleasure to sit by. No, today we're going to talk about a plumbing topic. We're going to talk about pressure in plumbing systems and,
About time.
and why it keeps creeping up and everything like that, or why you might have high pressure in your plumbing systems, whether it be residential or commercial type building and stuff like that. So that was a pretty cool one that we did for the 5 things.
Yeah, certainly a topic we get a lot of questions about on the tech line.
We certainly do.
Yeah, since we jumped on the scene with more and more plumbing products about a handful of years ago, yeah, we're getting more and more phone calls about this, and you know why the plumbing pressure is too high is kind of a big one. And I would start by saying that most of your plumbing codes are going to restrict the water pressure into a home or commercial business to 80 psi.
Okay.
So that is kind of one of the biggest drivers there with that is that, you want to maintain that pressure below that 80 psi for the sake of the fixtures. A lot of your fixtures are only rated to 80 psi too. And so there's a lot of liability involved to make sure that you're not over pressurizing those systems and causing any issues. And yeah, so one of the big ones that we talked about in the 5 things you need to know was where the water actually comes from. And in most municipalities, they're getting water from a well or some type of a source, and then they're putting it up in a water tower, which means that you've got this big elevation change between where the water's being used and where the water's being stored. And that elevation change can add a lot of pressure to that system to the tune of about 0.433 psi per foot. And usually in a water tower scenario, like in a small town where I live, it's not that big of a deal. But if you've got water, say like in a reservoir up in the mountains or something like that, it could be hundreds of feet.
That 0.433 psi per foot starts to add up real quick.
Pretty quick, yeah.
Sure does.
Yeah. And so yeah, I mean, if you're running into a lot of issues, I mean, chances are if you work in those neighborhoods, you know about all those guys that are having high water pressure issues. And then, I've even talked to Illinois, which is for us people from Wisconsin, we refer to the
Too far from us?
not too far from us, but we always refer to as the flatland, kind of thing. And so you how much elevation changes can you have in the state of Illinois? Trust me, I've driven through it. It is one of the flattest states that you're going to run into. But what they're doing in a lot of those municipalities there too is they're cranking up the pressure to distribute to be able to reach a little further out than what they could previously. And so there are some of those places where granted, they might not have a lot of high elevation, but they're running higher water pressure to be able to get that water supply out further and further as more and more subdivisions go up and things like that.
Not uncommon in those areas, too, to see that water pressure vary and fluctuate quite a bit.
Yep, and I used to deal with it. I'm sure you guys did too. Gas pressure and would do the same thing.
All
you
the
get
time.
Those heavy load days and stuff like that where, all of a sudden, your gas forced air furnace or boiler or whatever, it's not getting proper inlet pressure. It's the same thing with water. If there's more and more demand, the water pressure is going to drop off quite a bit, especially the further out you get. And so yeah, it can make a big difference. And again, if it's over that 80 psi, you need to do something about it. So typically what you're seeing in most applications is they're using a pressure reducing valve. And what's great about a pressure reducing valve, the name of it is it tells you exactly what it does. It reduces the pressure coming into those buildings so you can get it underneath that 80 psi and keep a safe, reliable pressure to those buildings. And that is one of our big products. It's even a global product for Caleffi, but we've been selling a ton of those guys, and we get a lot of questions about PRVs for sure.
Yeah, we sure do. And one nice feature with the PRV is that, if you set that outlet pressure, that inlet pressure can vary, and it's still going to maintain. So, I mean, if you have a PRV set to 45 psi, and your inlet pressure is fluctuating from 80 to 120 psi, it's not going to matter on the outlet. That PRV is going to control that pressure.
Right, for sure. Now, the one thing I would say is that obviously you put in a PRV because your pressure's too high, but there's sometimes that it's even too high for a single PRV in some cases, and so. In most cases, it doesn't matter if it's ours or anybody else's. In most cases, you're recommending no more than a 2-to-1 ratio inlet to outlet. So if say for example, if you've got 120 psi in, you typically don't want to set it more or less than 60 psi in the outlet. But we, in most cases, we can get closer to 3-to-1 ratios. But the problems you run into there is that a lot of times the pressure reducing valves can get they can get noisy. They can start to squeal and chatter and things like that. And that's something that you want to avoid. And so, I've run into a lot of applications, especially in like the North Carolina markets and stuff like that, where there is a lot of mountainous regions and a lot of elevation changes and stuff like that, where instead of actually using a single pressure reducing valve, they actually use 2 of them in series. And so they use the first one as a first stage, so to speak, to drop it from, to drop from like 200 down to 100 or 200 to 90 or something like that. And then they use the second one to drop from 90 to 60 or something, or something to that effect. So that way you're not doing it all in one valve, because that one valve, if you try to do that 3 or greater than 3-to-1 ratio across one valve, it's going to be a noisy little guy.
Yeah, it's going to be working pretty hard.
So, but the other thing we get a lot of phone calls about, when you talk about plumbing pressure and stuff like that, like chances are they already have a PRV in, but they're still running into issues with the pressure being too high on the outlet of that PRV. And one of the biggest ones we run into is dirt and debris. In your PRVs. What do you guys run into with that?
We see that a lot with dirt in the PRVs. It's typically when we'll get one back on a warranty, and the issue is it's being sent back because in their minds the PRV failed. Well, it won't maintain downstream pressure. The pressure starts to build.
Pressure's starting to creep up.
Yeah, so we'll take that, we'll pull it apart, and it's not uncommon for us to find debris in the cartridge. We'll clean them out, we can put them back in and pressure test them, and they work great.
Yeah, they work perfectly fine.
Yeah. And it makes me laugh too. I mean, there's a lot of pressure reducing valves out there that are less than favorable or less than fun when it comes to cleaning them. And I think that's one big advantage with our PRV at Caleffi is that you can pull that cartridge out in one piece. It's not 17 screws and 15 different parts and all that stuff. You can pull that cartridge out and you can clean it. And what I joke about is that for the time it would have taken somebody to just pull the cartridge, clean it, and put it back in, it would have been minutes by comparison to going back to the wholesale house and getting a new one, coming back and putting the new one in, and then having to go back to the supply house to take the old one back and do all the warranty procedure and all that screwing around. I mean, you talk about wasted time. I mean, everybody talks about time being so precious and how there's not enough labor. Well, you just wasted 3 hours sending a guy back and forth to the wholesaler to get a warranty. And I can tell you what, chances are the new one probably going to run into the same issue.
Well, yeah, and that's what Greg and I see.
Yeah, I mean, I had one contractor call me. He put in 3 different ones, same job. I said, did you pull the cartridge? Yeah, I pulled the cartridge. He didn't pull the cartridge because we got all 3 back. They had thread tape, copper fouling. They had like iron, little pieces of iron sand in them, all sorts of debris in all 3 of them. And I wanted to call the guy back and say, there's no way you clean these out. But at the end of the day, it's like, when I think he ended up putting a 4th one in, and we had the rep out there. I said, you need to purge the line.
To flush that.
And a strainer.
You got to flush the line. I said, I want you to put a bucket under the line before you even put this PRV back in the unions, and I want you to blow it off.
Yep.
Oh, look at all the stuff that comes out. Yeah. It's exactly why you're having the problem you're having.
Guys. I mean, you got to remember, we're here with tech support, and take the time and call us, because Cody mentioned it. By the time you take that PRV out, return it, get a new one, put it in, to see the same problem occur, we can talk you through pulling the cartridge on site. It's
flushing the cartridge.
Right. There's probably no PRV out there as easy to service as ours. Flush it out, clean it out, put it back in service, and we'll save you a return trip.
Yep. And having to have parts, because more than likely, if it's brand new out of the box, very rarely does something go bad right out of the box.
Right. And how many parts are involved with repairing ours?
1 cartridge.
Exactly.
That's it. Preloaded with all the parts, so you don't have to fight with diaphragms and springs and screws and any of that.
Yeah, exactly.
Yeah, and I mean, when you look at the inner workings of a PRV, I mean, it's allowing flow or allowing fluid past the cartridge in order to bring the pressure up on the outlet side, and if there is any dirt or debris in there, it's basically going to foul up that sealing element at the bottom of the cartridge, and if it can't seal off, it's going to require more pressure on the downstream side to kind of back pressure to help seal it off, and then sometimes it won't seal off at all. So, it's especially apparent. I've had jobs, especially new construction jobs, where they run a new water line and there's all kinds of dirt and debris in that new water line, and then they've got they're basically getting it all piped up in the house, and they might be running it during the day, but then all of a sudden from 4 o'clock in the afternoon until the next morning, nobody's there, and it just gives it all night to basically bring that pressure up little by little by little. And again, all it would have taken was a cleaning, a simple cleaning that would take 5 minutes,
flush the line, clean the cartridge, flush out the body, and you're set to go.
And that's and that's honestly one of those things you can look at as being a potential for upsell. I mean, if you've got dirty water, I mean that's a strainer, a media filter, whatever the case may be. At the very least, a strainer, but a good cartridge type media filter might not be a bad case there either.
And then some type of maintenance program to stand behind it.
Yeah, exactly. Yeah, get your feet back in the door there and everything like that. Repeat business. So the other big one that we run into quite a bit is the fact that pressure reducing valves kind of inadvertently they act a bit like a check valve, and so they allow water through, but they don't allow water back. I mean, unless the cartridge is all full of dirt and debris, like we talked about before. But anytime you talk about upsell and getting more on your tickets and stuff like that, the fact is anytime you put in a pressure reducing valve, you need to add an expansion tank as well, and then that's a big one because we've talked about this before with other chats with expansion tanks. Is if you that water doesn't have anywhere to go backwards or anything like that, and you've got a water heater in that system, that heated water will start to expand and it needs a place to go, and that's where the expansion tanks come into play. So if you are putting in a PRV, definitely look into putting in an expansion tank. Or, for example, if you're running into fluctuating pressures and you've already got a PRV and expansion tank, maybe that expansion tank is undersized or maybe it had failed or something to that effect.
Sure, and that's a symptom guys run into all the time, and we get a phone call. Well, I think the PRV's bad. Well, no. Do you have an expansion tank? Well, no. Or yeah, I do. Did you check it? Is it waterlogged? Well, I don't know. Or is it too small? Well, how do I size it? So those are all other things that kind of lead people start to point at the PRV when it's actually not the PRV. It's the lack thereof of an expansion tank.
You'll see that weeping at the relief valve on the water heater, and in some cases that could have that pressure in the building because of thermal expansion creep higher than even what the inlet pressure to the building to the PRV is.
Sure.
I mean, you might have a 120 psi pressure coming in, but because of thermal expansion, that building pressure will creep higher and it will go off at the relief valve if you don't have an expansion tank in place.
Yep.
Or a functional expansion tank.
Right.
Maybe it did fail. Yep. They don't last forever either. Yep. And so, I mean, anytime you're putting in a pressure reducing valve, definitely an expansion tank to go along with it. And in most cases, I mean, a lot of these municipalities are getting pretty stringent on their water. Once the water's been in your house, they don't want it back.
No returns.
Yeah. Well, and you look, there were PRVs on the market that had bypasses on them.
Yeah.
Yep.
And I still get questions, well, why doesn't yours have a bypass? Well,
yep. Yeah, so the idea with that bypass is that if the outlet pressure gets higher than the inlet pressure, it will allow water to flow backwards. It's like a little check valve. It basically allows backwards flow but not forwards flow through it. But with that in mind, the problem is that it's relying on the fact that your outlet pressure is higher than your inlet, which is funny because the chances, the reason why you have a PRV in the first place is because your inlet pressure is too high.
Right.
And so you're right. We do get a lot of phone calls about that. Is how come your pressure reducing valve doesn't have a bypass valve built into it, and it's really because it's just completely unnecessary. And if you've got inlet pressure higher than 150 anyways, you're never going to get bypass around that pressure reducing valve without having the pressure relief valve pop on your water heater anyways.
Plus, your municipalities don't want to see water coming back.
Yeah, they don't want it back.
It could potentially contaminate, the rest of the system.
Yeah,
correct.
For sure. Yeah, and so I mean, you're seeing a lot more municipalities requiring testable backflow preventers, whether it be double check or RP type backflow preventers, and again, inadvertently, just kind of a nature of the beast with a PRV, it doesn't want to allow water back, and a bypass valve really isn't. I wouldn't call it a feature anymore.
No.
It's something that you want to avoid
school.
sending water back. You want to keep that water in your system. So yeah, I mean, if you're ever curious about those bypass valves, I mean, there's some other manufacturers, you can see it in there how the bypass valve works. But again, it's relying on the fact that the outlet pressure on the PRV is higher than the inlet, which in most cases doesn't happen. That's the whole reason why you have a PRV in the first place.
Right. Yeah, it's kind of a sign that there's another issue. For sure. If you're relying on that bypass valve at all, I think you're doing something wrong. Right.
So,
right.
Yes.
So yeah, but yeah, I mean, that was the number of things that we did when we talked about why your plumbing pressure creeps up. I mean, just to talk about all the different reasons why it could potentially happen, and there's others too, but we wanted to hit on those the 5 most common things. And if you guys have questions, don't hesitate to reach out to us. Like Dan mentioned before, I mean, we've talked to a lot of different contractors, engineers, wholesalers. We've heard about a lot of different scenarios, and we can definitely use that information to help you too.
Exactly.
Absolutely.
All right.
Well,
All right. Well, you can tune in to the 5 things you need to know on our YouTube channel if you want to learn more and hear more from Cody. Otherwise, thanks for joining us.
thank you. Check
Thanks,
it out.
guys.
Thank you for tuning in. If you ever need help,
Please feel free to contact our tech support team anytime at techsupport.us@caleffi.com.
or call us during our business hours at 7:30 a.m. to 4:30 p.m. Central Time at 414-238-2360.